Okay, sorry, the last video cut off a little bit before I intended it to. We were checking something. Once again, when you do the domain of a composite function, you need to make sure that x is in the domain of the inside. And we were just checking b, the inside function is f of x. The domain of f of x is all real numbers except for -1. And -1 wasn't in the domain that we stated. So we were fine with this answer. Also in part A, the inside function is g of x, and the domain of g of x, that's this one, the domain of this is all real numbers. So this doesn't cause any domain issues. Really, the reason why we had to think about that directly for part C is because during the process of doing part C, we did some simplifying steps, and these simplifying steps can hide some things that aren't in the domain and make you think that there are numbers that are in the domain that really aren't because you did this simplification step. Anyway, let's do part D. This should be easy. This is g of x. G of x is, once again, it is e to the x. So g of x is e to the x, like that. And what's its domain? Well, I can do e to any power. First of all, let's talk about the domain of the inside. The domain of g of x is all real numbers because you can do e to whatever power you want. And so if I can do e to whatever power I want, then I can do this. And then I just have to do e to that power, and that would never cause a problem because, and I'm repeating myself here, I can do e to whatever power I want. So the domain is all real numbers. Okay. Now, to get you ready for the homework, let's do a few problems where we find inverse functions. So there's a simple procedure to find inverse functions. And I'm going to start with an easy one. So the first step is I just like to write y instead of f of x. The second step is to switch the letters x and y. Everywhere I see a y, I'm going to write an x. Everywhere I see an x, I'm going to write a y. The third step is to take that and now solve it for y. The answer that you get for y is f inverse of x. And this is how, by the way, this notation, it looks a lot like inverse trig functions, and that's for a reason. Inverse trig functions are partial inverses of the trig functions, and that's why we put this -1 here. And generally, if you have any function and it looks like you f to the -1 power, but this means inverse. And so the inverse function is whatever answer you got for y. Okay, and so the only part that gets interesting is basically step 3. Is after you've switched the letters x and y, which is step 2, you have to solve for y, and then that's step 3. And so, for that, it depends what equation you're looking at, and it can be very different, the methods that you use to solve for y. So let's do part B. So first I write y instead of f of x. Then I switch the letters x and y. Then I solve for y. This one's going to be harder. Fundamentally, that's because I'm trying to solve for y and it's showing up in two places. It shows up in the top and in the bottom. Here's what I'm going to do. I'm going to multiply both sides by this bottom. Of course, on the right, that just cancels the bottom and I get y minus 2. On the left, let me distribute this. So I'm multiplying x by this. I'm going to get 3xy plus x, because that's x times 1. So I'll go up here and keep going. I want to get y by itself. And in a way, I've only made things worse because y is still appearing on two places, and now they're not even on the same side of the equation. Let me fix that part. I would like all the y's on the same side, and meanwhile, I would like any term that doesn't have a y to be on the opposite side. So I'm going to pick a side for my y's, and it doesn't matter if I pick the left side or the right side. Maybe I'll put all the y's on the left. So I'm going to keep this term here. That's going to remain on the left. I'm going to move this over, so that becomes a minus y. Meanwhile, I'm going to move this one away from the left because this does not have a y on it. The left side is the side for all of my terms that have y's on them. So this does not belong anymore. This is going over to the right. That's going to be a negative x. And what else do I have on the right? Well, I have this negative 2. This negative 2 doesn't have a y on it, so it shouldn't move to the left. It should stay where it is on the right. Okay, now the rest is easy. I'm going to factor y out. And then finally, y is just going to be this divided by this. And that is the inverse function. Great. Let's do another one. So I've got this. Step 1 is to write y instead of f of x. Step 2 is to switch x and y. Step 3, solve for y. Fortunately for us, y is only appearing in one place, so I'm focusing on this y, and I would just like to move everything else away from the y. So the first thing I'm going to do is divide by this 2. Now I'm going to get rid of more things that are surrounding the y. I'm going to get rid of the natural log. And remember, the way you do that is by what I'm about to do is I'm about to apply the inverse function of natural log to both sides. The inverse function of natural log is e to the x. So I'm about to do e to this side and e to this side. What happens when I do that is I get e to the x over 2 equals, and then this and this basically just cancel, and I just get 3y minus 4. Okay, so I'm making progress on my mission to get rid of all of the things surrounding the y and ultimately just get the y all by itself. I'm not there yet. I need to add 4 to both sides. and then divide both sides by 3. Oops. All over 3. And that is the inverse function. Just like that. Okay. Just 2 more quick examples, because on the homework I realized I didn't do any that are quite like this. Solving inequalities with exponentials and logarithms. It's not so hard, I just want you to know what to do. So let's solve this for x. And I'm going to start by doing some things that we know that we're allowed to do with inequalities. So I'm going to subtract 1 from both sides. I'm going to divide both sides by 2. I'm dividing by a positive number, not a negative number, so I'm not going to switch the direction of the inequality. So log base 3 of x is less than or equal to 3. And now here's the step that I just, like, this is the reason why I'm doing this example. This is like what maybe you haven't seen me do before. What I'm about to do is I need to get rid of the logarithm. And how would I normally get rid of the logarithm? I would do the inverse function of log base 3, which is the function it's the function 3 to the x. In other words, what I'm about to do is I'm going to do 3 to this side and 3 to this side. And by the way, this is entirely analogous to when I wanted to get rid of this logarithm on the last example. I did e to this side and e to this side because natural log is log base e. That's why I do e. So when I do log base 3, I do 3. And what I'm about to tell you is you're allowed to do this to both sides of an inequality. And you don't reverse the direction of the inequality or anything like that. So the solution is that x is less than or equal to 3 to the 3, which is, of course, 9, right? No, it's not. I tried to trick you. 3 to the third is 27. This is a common mistake. Right? 3 times 3 is 9. 3 times 3 times 3 is 27. Anyway, there we go. We can put this in interval notation if we like. This would be the interval from negative infinity to 27, including 27. Okay. Similarly, for part B, I've got this. X is just showing up here. I want to get this by itself. I'm going to add 2 to both sides. Divide by 3. And now I need to get rid of the, like this. I need to get x out of the power. So what I'm about to do is the inverse function of e to the x. I'm going to apply the inverse to both sides. The inverse is, of course, natural log. And the main reason why I'm showing you this is, once again, to emphasize that you can do the natural log of both sides of an inequality, and you keep the inequality going the same direction. And of course, this just cancels the e. The natural log of e to the x is just x, and so I get this. X is greater than the natural log of 2. The natural log of 2 is not it can't really be simplified. It's a number. If you put it in your calculator, it's 0.6, blah, blah, blah. The decimal goes on forever, actually. So this can't be simplified. It is what it is. It's just a number. It's just the natural log of 2. So how would I put my answer? I would say the interval starting at natural log of 2, not including natural log of 2 because it's not greater than or equal to, and it goes to infinity, and so there's parentheses on both sides. Okay, that's it for today.